I'm going to show you how to analyze a series circuit. It's important to remember that series circuits have two things that are always true. In a series circuit, there is only one loop, so there is only one current. I will label that I sub B for the current out of the battery. This current flows through all the resistors in a series circuit. The second thing that's true is that the voltages on the resistors add up to the voltage on the battery. You can think of this using the chairlift and ski analogy, that the elevation you gain on the chairlift is equal to the elevation drops as you ski down the mountain through the moguls. The next step is to draw and label a schematic. Here I've drawn a schematic showing 3 resistors connected in one loop in series. I've labeled the battery voltage, the current out of the battery, and I've labeled each of the resistors 1 through 3. In this example, I'm going to use the following values for battery voltage and resistance. The next step is to find the equivalent resistance for the circuit. For a series circuit, you simply add the resistors together. In this case, the equivalent resistance is 60 ohms. The reason we begin by finding the equivalent resistance is because with this resistance, we can find the current out of the battery, I sub B. This can be found by taking the voltage on the battery and dividing it by the equivalent resistance. In this case, we have a battery current of 0.2 amps. This same current flows through all the resistors. Next, we find the voltage on each resistor using Ohm's law. The voltage is equal to the resistance times the current. Here I've worked out the voltage on all 3 of the resistors. Notice that they add up to 12, which is the voltage on the battery. Next, we find the power from the battery and the power used by each of the resistors. The power from the battery is the battery voltage times the current from the battery, which gives us 2.4 watts. The power on each of the resistors is the voltage on the resistor that we previously calculated times the same current. With this, we can build a complete table for the circuit. Here I've listed the resistance of each of the resistors, the voltage on each of the resistors and the battery, and the current through each of the resistors and the battery. And then I've calculated the power from the battery and delivered to each of the resistors. Once you have this table, it's very easy to check if things have worked out correctly. Let's go back to what we know. First, there's only one current in a series circuit, and sure enough, we have listed a single current for each of the values in our table. Second, for a series circuit, the voltage on the resistors adds up to the voltage on the battery. Here we can see that indeed 3 plus 4 plus 5 equals 12. These 2 tests are true for series circuits. There is a third test that is true for all circuits. It's based on the conservation of energy. It says that the power that comes from the battery must equal the power used by the resistors. And we look here, we see the power from the battery is 2.4 watts, and the sum of the power from the resistors is also 2.4 watts. In this way, we know we have correctly analyzed the circuit.